Hey everybody, welcome back. I'm Deez. This is my workshop. Today we're going to make another shop-made tool, but it's for tramming in the mill vise. And today I want to make a tool that will allow me to attach to the milling head in order to put a dial test indicator on it and be able to extend to the ends of my table. This is a 27-inch table on the mill, and I want to be able to tram in the head or a workpiece that's really long to both ends of the table. And that way I can really know if this head is truly trammed in or not. The way that I've been doing it right now, I really only have a 6-inch usable span with the tool that I have. So today's project is to make something that I can extend that out and actually tram in both ends as far as I can with a tool. Now, this is going to be inspired from a type of tool that Blondie Hacks uses when she trams in long pieces on her mill, and it's basically a piece that will go into the headstock, and then there's a long rod that you can swing back and forth to check out the tram. So I'm going to grab my workbook here, we're going to draw out kind of a conceptual idea, and then we're going to go look for some materials and figure out what we want to make. Who knows what it'll end up looking like, but I do want it to be able to be adjustable. I want it to have a slight angle on it so it'll reach down for both ends. Hopefully we'll be able to tram this mill in a little bit better, or at least check the tram to see how far I'm out. I suspect that I'm out 1 to 2 thou over an 8-inch span, maybe 2 thou. I don't know. Could be more. I gave a work piece to a friend of mine, and he checked the tram of it, and it was a real short piece, but he mentioned it was like 4 thou out. So if I'm 4 thou out over a really short, small span, I'm not ever going to be able to square up material properly, or at least within a thou. That's going to be the focus of today's project. Let's grab our workbook and get to drawing something out. Let's get an idea in our head. Well, apologies once again. I got to run the air. It has just been stifling here in the Midwest, but that's okay. I'm in the workshop. We got a little bit of comfort going on. I just turned it on, so it should start cooling down here in a little bit. Before we get started drawing this out, I thought I would share some little birdie signed me up for the home shop Machinist. It's actually a pretty good magazine. I've got a few copies here in my little metal box that we restored that were shared with me in the past. They're pretty good magazines. If anybody's interested, I don't have any affiliation with these guys. There's Machinist Workshop, that's a magazine subscription, or Home Shop Machinist. Magazines are kind of hard to find anymore. Everything's going digital. I'm sure these guys have a digital version, but sometimes, at least if you're old school, you like to pick up a magazine, sit and relax, thumb through it, check out some of the articles, some of the advertisements. It's not the same as browsing the web. This just, somebody presents this information, they put it together, they give it to you, and you just thumb through it, and you're going to be inspired or find some ideas you didn't know about, or information that you weren't even aware of. Really interesting. The Indiana Model Engine Show, they got an ad spot in this month's catalog or issue. That's pretty cool. Again, I attended that last year as an attendee. I wasn't exhibiting anything. It's a pretty interesting show. If you're up in the Auburn, Indiana area, northern Indiana, central northern Indiana, you might check this thing out if you're interested at all. It's a really good show. There's other articles in this issue. I haven't been through it all. And on the back, of course, Precision Matthews. I can vouch that they do make a good, solid product. You have a mill. Again, no affiliation with them either. They didn't give me anything. I had to buy it. Regardless, let's get down and start this project and draw out what I've got in my head for what I'm trying to accomplish. Well, we got it drawn out, and this is probably one of the worst drawings I've ever done, but I got my head wrapped around what I want to do. Basically, we want to build maybe a 1 inch, maybe 3/4 inch, probably try to get a 1 inch rod that will go into an R8 collet, and I'll make that 4 or 6 inches in length, and then we're going to drill a hole in that rod at a slight angle, 10-15 degrees. I got to still figure that out, exactly what angle I'm going for. That way I've got the downward rod length to where it'll come down to the table. And then I need a 12-inch half-inch rod. I want something rigid, but I need enough material to where it doesn't flex, and I can actually drill and be able to figure out a way to fasten my dial test indicator to that rod. So that's we need the length of something that's thick enough to where I can still mount the dial test indicator, and it will be rigid, and I can also get it into the portion that will mount into the quill. My ideas for doing that are just to make a slip fit through hole, but that's my idea. I think this will work out. Next thing we need to do is go shopping for some material and bring it back here and just kind of wrap our heads around where to start. Let's see, how do we want to do this? Something roughly a foot long, and we want to gauge, we're wanting to be able to mount something and it come all the way out to either side. And I think an angle about like that ought to do. Well, I like the 20 degrees. It's roughly, it doesn't have to be exact, but I think 20 degrees is going to work out fine. I can always bring the headstock up and down in order to get the angles and everything right that I like. I also think that distance on that rod is about the right length, but I do want some extra because my mounting system, I'm actually going to run through how it mounts, so I can adjust the rod that way as well. So this rod is 11 inches. So I'm thinking I'll want maybe 14 inches should give me plenty of adjustment and get me all the way out to the ends. That's 28 inches plus the distance of the indicator. So 20 degrees it is. We'll put that one there like that because we're going to use it. Set this aside, and now let's go through our materials. I'm just using scrap for this project because there's no reason not to, and I have it. These are materials that my brother gave me. I could use this bolt, cut the head off, and there's plenty I only need probably 4 inches, I think, is what I'm guessing. The only problem with this doesn't give me the mounting system that I have envisioned. Enough room for that without turning down. Well, it's just not quite thick enough, I don't think. So I think since I have this other piece and it's much larger, I'm going to go with this. Now, I do see a potential issue. There's an old pin here that is probably a tapered pin. I might see if I can try to pound that out of there before we get started. Actually, it looks like a split, maybe like a roll pin. I want to see if I can get that out of there. I would assume that's going to be hardened or it'll be an intermittent cut. I might have some trouble. But the idea is to turn down, I don't know, about 1 inch of this material. I'm thinking 3/4 of an inch so that it fits my R8 collet. And then that will mount in there like that. the mounting system for the rod will be through here at a 20-degree angle. It'll work out, I'm pretty sure, trust me. Now the mounting system, I was going to use this 1/2-inch rod. It's very rigid. I think we got a good plan. First thing is, let's see if we can get this roll pin out of here, and then I want to turn down a portion of this to 3/4 of an inch. That was just an old split pin. You can see we got that out of there. Had to drill it. It was mushroomed over inside there. It wasn't coming. But we got it drilled out. You can see the hole through there now. Now I don't think we'll have a problem, although this could be really hard. If this material is really hard, I'm going to find some different steel. I have some other steel that I can use. But let's see how hard this is first before we abandon it, and we'll get to turning. I'll probably just turn this completely out, get rid of that. I don't know. I might leave it. I just need to turn this down to 3/4 of an inch. I don't know, about an inch or two down, probably an inch down, and then this other end shouldn't matter so much. I need to be able to hold this in my collet. I ended up, because there was so much material, this was about 1.25 inch thick piece of steel, I went ahead and stopped at 7/8 to take less material off. We got it chamfered, faced off, this slides on here nicely, and that's going to tighten down nicely once it's all mounted up inside the headstock. So that's what we were going for. This portion is good enough. I don't need to turn it down any further. I think what we'll do now is turn this around. The piece is really done other than drilling the hole. What we'll do is turn this down, we'll chuck it up on this portion here, and we'll just clean up the OD just to have it nice and clean. So we're not really looking to take much material off. We're just going to clean up the OD and face, and then we'll chamfer all the edges so it's nice and safe. And this piece, the lathe work for this piece should be done. Then we'll head over to the mill, figure out how we're going to set this up to drill our hole at 20 degrees through the base. Well, everybody, we got our part made other than the hole that we need to drill. I decided that I'm going to use this zinc plated round bar. Now, I know zinc coatings, if you get them hot or you burn them off or you turn them, this can be dangerous for you. The coating can't be good for you to breathe in and that sort of thing. I don't intend on turning this down. It's a 1/2 inch rod. I'm not sure what I'll use this for otherwise. So I decided to go ahead and use this zinc round bar. I'm going to cut it down to 12 inches. That way I can cut, I don't have any larger diameter drill bits. The math doesn't add up with what I have in possession, and this is going to end up being rigid enough and work out just fine. So I'm going to cut a 12-inch piece of this round bar off. We'll turn down the ends, we'll get it cleaned up, and this will be our rod that we're going to use. I may go ahead and just use a set screw. The set screw is going to be easy. It's going to be perfect for the needs. It doesn't need to be too fancy. So I had to figure out how I'm going to hold this piece. We'll do that in the mill. We're going to use this 20-degree angle block that I have, and then on the very end, we need to drill a hole. Now this one I will use a set screw, and I'm going to use this little mounting device here that goes onto my dial test indicator, and this will go into the end, and the set screw will hold this in, and everything will be nice and secure that way. I think the next thing we need to do, let's go ahead and cut this rod down. Let's get a 12-inch piece of rod here, then that'll be ready to go. We're going to take this really slow. We're going to use oil. I'm going to use a spotting drill, and we're going to bring this thing in. I'm going to measure down maybe a 1/4 inch, and that'll be the low spot. Let me figure out where I'm going to put that, and then we'll spot it and we'll drill it to 1/2 inch. To leave a 1/4 inch gap down here, which I think is a good idea, I'm bringing it up a 1/2 inch total. 1/2 inch back is your drill bit, so that's going to be 1/4 inch either way, and that will go down, and we have plenty of clearance. Well, that was frustrating. This is exactly how not to do something. I'm gonna have to do some research and figure out what's a good setup method to drill an angled hole in a round stock. There's got to be a better way. Clearly don't know what I'm doing. I got clamps and everything everywhere. This part's moving around. This is not what I was hoping the outcome would be. In the end, I used a crappy drill bit and it got through half of it. It's toast, that drill bit. I might be able to sharpen it. Maybe I'll practice that. I went ahead and went with my Cleveland drill. It went right through it. It's good now. I just didn't want to ruin this drill, but I think we're good. That's why I bought these things. That thing went right through it. Now I need to chamfer this, take this part out. We'll go examine it and see if the hole is too big now, and we'll see what our next steps are going to be. Clearly, I got a lot to learn. This is not how you would normally do this. Let's get this part out of here. Well, we got that. Let's go over to the workbench and check things out a little bit closer. Well, I think I got a name and a title for this video, and it's going to start with how not to. What a joke. I split that. I've got a lot to learn. Let's just put it this way. At setups, this is all about setups. Being able to drill a hole at 20 degrees in some round stock, there's a better way to set this stuff up, and it's not with the equipment I have, and maybe it is with the equipment I have, and I just didn't do it right. I clearly don't know what I'm doing when it comes to this particular type of project. I appreciate, I'll just say this, anybody that has suggestions, I love them all the time. Everybody puts your information out there, says you're doing this wrong or that wrong, here's a way to do it. I would really appreciate all the feedback. How do you set this thing up solid, in a solid way, so that it will cut a 20-degree angle through your material without all the muss and fuss that I went through. I screwed it up, but it's going to still work for what I need to do. I could always cut this off and do it again. I think this is going to work fine. I want to get this cleaned up, and we'll just make sure that the rod and everything's going to fit like I want it to. I wanted to share this with you. You should be able to see that. This is you guessed it, Harbor Freight drill bit, but that is mangled. There's a burr there. You can see that. Big old bent burr there. I couldn't get through that material. I think I might have hardened it, work hardened it a little bit. You see that shiny spot there? This drill bit's toast. I may practice grinding, and this would be a good drill to practice that with. So that might be something that I try. It's not a split point, so I may try that. But this half-inch drill is toast. I put a little X mark on there because it's junk. To finish the project, or at least get through, I ended up going with my Chicago Latrobe, good old drill set. These things are really nice. I was hesitant because I didn't want to damage this drill, because I fear that was a little work hardened. There's a little bit there. How's this one? Yeah, I don't think I ruined this bit, but I didn't do it any favors finishing that project. But this is a really good drill set. So that rescued me, but I don't have any other half-inch drills. I'm gonna have to pick something up. You can see there, I split my, again, everything I did was wrong here. But I shouldn't have used nylon. This thing, I needed too much pressure. I think what I'm gonna do is just cut this back and have a really small V-block for future projects. But this is toast. Ruined that, which is fine. These are sacrificial. Here's my 20-inch gauge block, but these just aren't quite big enough for setups in that vise. I mean, I like them, and it was cheap enough, but it's just not quite right, these things. At least using in a mill vise. And I'm probably just doing it all wrong, but that was part of the problem. I ended up just cramming a bunch of material underneath this thing to get it to stop moving around. I should have just had a better setup to begin with, but I didn't. It's what I had, and we got through the material, but man, I really screwed this up. That's disappointing. Let's go ahead and deburr it. Some of those big chunkies off, and then I'll use a deburring tool to get the rest off, but there's some pretty big chunks there. Well, we got this deburred. Golly, irritates me. Screwed that up so bad. But the idea is this will go into a 7/8 inch collet. Let's see if this 1/2 inch rod goes in here. I'm sure it will. It's just wallered out so much. It fits, but I just need to, I think, run a little sandpaper in there and clean that up. But this is work. This is going to work just fine. It's nice, and that's just a burr. From there. So we'll be able to mount that into the headstock. We'll be able to swing this around in order to tram in the vise. That fits really good. It's just aesthetically it looks like trash. You can see I boogered it up. This fits really good. Now I just need to decide, do I want to do a slotting saw and then drill and tap, or just drill and tap a hole? I think I'm just going to drill and tap a set screw at this point. I know that's tried and true. I don't want to do something and then it ended up making it worse. I think a set screw is just going to be perfect for something like this. And we will set this up in the collet chuck to do that operation. And I'm just going to come in, somewhere in here. We'll put a mark in there and we'll drill and tap for a set screw. Let's take this over to the lathe. I want to go over and do some lathe work first before I get back on the mill. And we want to face off both ends, chamfer them, and then we want to drill a hole to fit this holder, which is 160 thou or so. Let's double check that. I think it's a number 20 twist drill, which I have. 157, so I'll do 160 thou, and we will also drill and tap for a set screw for that. getting to the home stretch. Now we need a collet block. We got our 7/8 collet. Fits in there nicely. And we're going to center this up, and we're going to drill and tap for a set screw. You got there? Okay. all the components made and all of our things ready to test this setup out. We aren't going to tram the mill or anything today. I just want to do a proof of concept, get everything mounted in there. But we're going to use this 7/8 R8 collet to mount everything. That will go on this shaft. Then this rod is going to slide in here at whatever depth we feel is necessary. Still got a little burr. Oh, might be a little too tight. That won't go anywhere. And then finally, we are going to mount our dial test indicator using this little mechanism here. We can tighten that down with a little screwdriver if we need to. And this will slide in here. And this will tighten down on that. And that will hold everything together. So now the idea is to get this on the mill. Let's go ahead and tram or test tramming 1, 2, 3 blocks and just see what we come up with. There's our setup. We got a nice rigid setup with this dial test indicator now. So now I'm going to bring you down a little bit closer and we'll just see how much rudimentary runoff we have here. This isn't going to be an official tramming. I just want to give a demonstration and we'll close this video out. We got everything cleaned up. Let's check our tram. I know this can flex. I mean, you got to be real super careful. So that's a little bit high. Let's bring that down. We have that on 0. So hopefully you can see that is on 0. We're going to swing this over and check the tram on the other side. I think this is going to be 4 thou out, a couple thou out, but we'll see. So let's yeah, that's way out. That's showing 7 thou over a 24-inch span. Let me reset some of this and we'll try this again. I tested it off camera and actually was on spot on, which something was wrong. Let me clean everything again, make sure there's no burr or something on something. I mean, 7 thou is very, very off. If this is 7 thou out, I'm never going to get anything square. Okay, I cleaned everything up. We're still off but this is a little better, a little closer to what I was thinking it would be. 1, 2, 3, 4 thou, a little under 4 thou out. But let's check. Right now, I'm just under the 5, so about 4, just under 4 thou out. We swing this around. Bring you over here. And you can see that it is on the 0. So we're about 4 thou. That's what I was expecting, not 7 thou. We're about 4 thou out from one end to the other. And the reason that I knew that is when I was using my fly cutter or face mills, it would only cut on the leading edge. It didn't cut on the back side. So I knew that my tram was off. The other thing I need to tram is to make sure the vise itself is trammed in and level. You know, that these parallels are parallel with the bed. I suspect they are, but I think I need to adjust this headstock by 4 thou. I think I can get some of that out of there, at least within 1 thou. We're going to give it a try, but I'm going to do that in a different video. I just wanted to give a demonstration of the tooling that we made and why I created it, how it's going to be useful for keeping this machine in check. You can see, I think it's 3 thou out. It's between 3 and 4, but if we look at 3, you can see that we're 3 thou, 0, 1, 2, 3. We're not going to cut the shot here. Let's go ahead and swing this around and see what we end up with. Sorry, no trickery here. Okay, and there you go. So it's actually 3 thou out. That's not bad. That's really not bad, although it's not perfect, but I don't know if I'll achieve perfection. Let's swing that back around one more time. Try to keep you in shot. Let's see if I bump. I'm trying to hold it at the very top so I don't bother. I did bump the quill arm there. That could mess it up. There we go. What are we at? Whoops. Yeah. So we are 3 thou. I'm pretty happy with that, although I do think I can take some of that out. Let's do one final pass. Again, there's 3 thou out. There's 3 thou out. See if we repeat that again. And we're on the 0, so we are 3 thou out. Repeatable, confirmed multiple times. I'm actually quite happy with that, to be honest with you, but I do think at some point I'm going to try to take some of that out of there. But 3 thou over it's a 27-inch table. This is about a 24-inch measurement from one end to the other that I'm actually testing. 24 inches, 3 thou out. That's pretty accurate for a home hobby workshop. The tool turned out well. It works well. I'm able to tram in long distances now. That's a 24-inch span. As you can see, I've checked it several times and we are 3 thou out. Not 4 thou, not 1 thou, which I first checked. I've got everything cleaned up. Everything as clean as it's going to get, and I'm holding the quill as high and tight as I can, and we are repeating 3 thou out. I'm only cutting on one side of my cutter, which is actually, it just means that the tilt of the head is a little bit lower on the left side. It's not that the table is off, it's that the head is tilted downward slightly. 3 thou from one end to the other. Overall, that's not too bad. I'm pretty happy with that over that great of a distance. However, I think I can improve it with this tool and this setup. All I got to do is loosen this up, knock it a little bit, just to take one and a half, maybe 2 thou out and get it to 1 thou, I'll be perfectly happy with that. Proof of concept, and the tool is functional, it works. I'm really happy with it, and I think it's going to be very useful in the shop for many years to come. So with that said, I'm going to bring this project to a close. I hope you enjoyed. Thanks for watching. If you haven't subscribed, please do. It really helps out the channel, and I hope to see you on the next one. Thanks for watching, everybody.